Right, this next part is in all about basically what can come about from the scalar product and different things that arise by using the scalar product. Okay, so one of the things is dealing with perpendicular vectors. Obviously, perpendicular is when they're at 90 degrees to each other, this can basically lead to certain things in terms of the scalar product because obviously we're finding an angle. And when we're dealing with exact values, obviously we know the exact values of things like cos 0 and cos 90, and they're the main two that you need to look out for. Because as long as they are exact values, it makes the calculation a little bit different, okay? So gradients can be used to identify perpendicular lines in 2D only. So in 3D, we have the scalar product to help us identify them when vectors are perpendicular, okay? It works in 2D as well, but we're mainly going to see it when we're dealing with 3D. So you've basically got these two instances, and these are just the kind of the converse of each other. So if, pardon me, if a dot b equals 0, then it tells us that the magnitude of a times by the magnitude of b times by the cosine of the angle between them must equal 0. Okay, that's just going by the formula. A dot b equals that, in which case if a dot b equals 0, then that must also equal 0. Okay, therefore, because we know that the magnitude of a and the magnitude of b are not equal to 0, okay, if they were equal to 0, then they wouldn't actually be vectors in the first place. So if they're not equal to 0, it implies that cos theta must be the bit that equals 0. Okay, if we're timesing two numbers together, we won't ever get an answer of 0 unless one of them is 0. But we know that a and b can't be equal to 0 because they both have lengths. In other words, the bit that we have to have equal to 0, because we have to get an answer of 0, must be cos theta. Therefore, if cos theta equals 0, we know that theta must be 90 degrees. Okay, just going by exact values, looking at the graph, whatever it is, if cos theta equals 0, then theta must equal 90 degrees. Therefore, the angle between the two vectors is 90 degrees, and thus vectors a and b are perpendicular to one another. Okay, so if you asked basically to prove that two vectors are perpendicular, you can use this method, but this is basically telling us what happens when we have a scalar product equal to 0. So if a dot b equals 0, then it must mean that the two vectors that we're dealing with, a and b, must be perpendicular to one another. But the converse of this, as I say, is if we're asked to prove that they're 90 degrees from each other, okay, then we know that cos theta will equal 0, in which case the magnitude of a times by the magnitude of b times by the cosine of the angle between them must also equal 0. In other words, a dot b will equal 0, okay? In other words, we basically just got two ways. Either we're proving that it's perpendicular or that we know that they're equal to 0, and we're writing what that basically tells us, okay? So if a dot b equals 0, then the theta equals 90 degrees and a is perpendicular to b. And conversely, if a is perpendicular to b, in which case theta is 90 degrees, then a dot b will equal 0. But basically, just look out for this. If a dot b equals 0, then you know they're 90 degrees to each other. And if you ask to prove they're 90 degrees to each other, then you prove that a dot b equals 0. So, for example, you might have a situation like this where you're not actually going to use that formula, that version of the formula. This is where you're going to use the other version of the formula, okay? In which case it's a1, b1 plus a2, b2 plus a3, b3 to show that they're perpendicular. So if these are going to be equal, if these are going to be perpendicular, then u dot v will equal 0, okay? So we need to show that first of all, in which case we need to find 3 times 2 plus 2 times minus 3 plus 0 times 4, and that does indeed equal 0, which does tell us that they are perpendicular. So if that's a proof, then that's what we want to find. We want to find that u dot v equals 0, okay? So a second type of example is that we know in advance that they are perpendicular, and using that knowledge, we want to find out what k is. So if a and b, and you might see this kind of, this notation, a with a kind of an upside down t, b, that means that they're perpendicular to each other, they're 90 degrees to each other. And if that's the case, then a dot b will equal 0. In other words, 1 times by minus 1 plus 2 times by 4 plus whatever k is times by 3 should equal 0. And then it basically leads us to an equation. Okay, 1 times minus 1 is minus 1, 2 times 4 is 8, 3 times k is 3k, in which case 3k is going to have to equal minus 7, okay, in which case k is going to have to equal minus 7 over 3. And that's if they're perpendicular. So if we knew that in advance, then we can find out what k is. Okay, so properties of the scalar product. So this is, again, the kind of idea. If you have a situation like this, okay, if you were looking for something like a dot b is exactly the same as b dot a, okay? If you have something like the second one, a dot and then in brackets b plus c, that is what you'd think, okay? It's not like your trigonometric expansions where there's a whole different formula. It is literally just a dot b plus a dot c. So quite often you get this as part of your question. This is the start of your question, and you'd want to expand it into two individual scalar products, a dot b plus a dot c. And there's a couple of things based on this that's also useful to remember. You can kind of work these out for yourself, but it'll save you a bit of time if you kind of remember it. If you have a dot a, in other words, you're finding the scalar product of two of the same vector, that's going to be equal. If we put it in the formula, this will work out. It's going to be the magnitude of a times by the magnitude of a times by the cosine of the angle between them. But if it's the same vector, then there is no angle between them, so the angle between them is just 0. Cos of 0 is 1. Okay, so this just simplifies basically to the magnitude of a times by the magnitude of a, or in other words, the magnitude of a squared. You don't have to remember that. As I say, you can work that out for yourself, but it'll just save you a little bit of time if you do. If you go straight from a dot a to the magnitude of a squared, it'll just save you a little bit of time. But it's useful to note all three of those things, okay? Right, so here's an example, and yeah, I've not put the animation on this, so it's just come straight out for you. But if you ignore the bottom half here, we said that if the magnitude of p is equal to the magnitude of r, which is equal to the equal to 3, and then the magnitude of q is 4, what we want to calculate is p dot r plus q. Okay, so in a situation like this, the first thing you want to do is multiply out the brackets. So p dot r plus q is going to be p dot r plus p dot q. P dot r, based on what we've got, so we don't have component form here, so we want to use the second version of the formula because we're dealing with magnitudes and angles. So p dot r will be the magnitude of p times by the magnitude of r times by the cos of the angle between them. We can see from the diagram the angle between p and r is 30 degrees. And then p dot q is the magnitude of p times by the magnitude of q times by the angle between them. And we can see that it's both 30s that are between p and q, in which case the angle between them is 60. Simplify this down, or put in the values that we know. P and r are both 3, so it's 3 times by cos 30. P is 3, q is 4, 3 times 4 times by cos 60. And obviously cos 30 and cos 60 are exact values. Cos 30 is root 3 over 2. I'm going to times that by 9, and then add on 3 times 4 is 12. Cos 60 is a half. So in the simplest way possible, 9 root 3 over 2 plus basically 6, or plus 12 over 2, in which case 9 root 3 plus 12, all over 2. Okay, straightforward enough. It's just using a couple of different processes there. As I say, the main thing is as soon as we've got the dot product now, then we've got two versions, two options to use from there. So we have to make it relevant to the question that we've got. We don't have anything about components here, so we can't use the A1, B1, A2, B2. We have to use the magnitudes and angles formula. Okay. Right, this is a past paper. I'll maybe write it out. Okay, vectors u and v have components, blah, blah, blah. Find an expression for u dot v. Right, so this one now we have the components. Don't know about magnitudes, and I'm not going to be able to find magnitudes as long as I've got p's kicking about. So the only version I've got to use for u dot v is the whole a1, b1, a2, b3. So all I can do here, I can go u dot v equals, and then it's p times by 2p plus 16 plus minus 2 times by minus 3 plus 4 times 6, okay? P times by 2p plus 16 is going to be 2p squared plus 16p. Minus 2 times minus 3 is 6. Careful your negatives. 4 times 6 is 24. And that all simplifies to 2p squared plus 16p plus 30. And that's an expression for u dot v, okay? Right, I think I could have left it in the first one, but the point is I'm going to want this. You can kind of see as soon as you get something like this, you know you're probably going to have to factorize or something at some point. But what we're trying to do is determine the values of p for which u and v are perpendicular. Okay, so this is the jump that you need to be able to make. So this is using the stuff that you've known from before. If they're going to be perpendicular, then the angle between them is going to be 90 degrees. If the angle between them is 90 degrees, then we're going to have the dot product of a and b, or u and v I should probably write. U dot v will equal the magnitude of u times by the magnitude of v times by the cosine of the angle between them, which is 90. I know that cos 90 is just 1, so this is just going to be u dot v, sorry, cos 90 is 0. This is just going to be equal to 0, okay? Doesn't matter what the magnitude of u is, doesn't matter what the magnitude of v is. If they're perpendicular, then u dot v will equal 0. I've now got an expression for u dot v from the first part, in which case, if I'm going to determine the values of p for which u and v are perpendicular, then 2p squared plus 16p plus 30, why has this got thicker, will equal 0. That's really annoying. Okay, anyway, That's now an equation that I can solve, and I want to solve it for p, in which case I'm going to need to deal with the left-hand side. It's fine as it is. Everything's on the left, equal to 0, so I need to factorize. First thing I can do there is take out a common factor. P squared plus 8p plus 15 equals 0, and I'm basically dividing both sides by 2. And then I can factorize. I'm going to get, can I squish this in the bottom? P and p equals 0. I want the factors of 15, add to give me 8. Obviously 5 and 3, plus and plus. So p will either, let's go thin again. P will either equal minus 3 or it will equal minus 5. And that's it. Okay, so that's the values of p for which u and v are perpendicular. So there's a little bit of a jump there, but it's using perpendicular, you're thinking angles, hopefully you're thinking 90 degrees, and then if you think about angles and 90 degrees, then you're using this version of the formula, thinking how it is affected. As I say, you either just remember that it means that the dot product or the scalar product will equal 0, or you think about it and actually put it in the formula. You're going to get cos 90 in that case, in which case it's going to all equal 0. So for the last one, determine the value of p for which u and v are parallel. This kind of links back into something we were doing before, in which case what it means is there's a scalar between the two of them, in which case u is basically a scalar of v. In other words, u times by something should give me v. And what I can do there is I can look at basically the two here, okay, the two bottom components, and see what the kind of the connection between them is. If to get from 4 to 6, I basically need to times by 1.5. That does still work from minus 2 to minus 3. If I take minus 2, if I got 1.5 minus 2s, that does equal minus 3. And what that tells me, therefore, is that p times by 1.5 will equal 2p plus 16. Okay, you can use 3 over 2. It's basically 3 halves of 2. It's an extra half, so 3 halves. Either way, we can find the answer by solving this. So we've got 1.5p equal to 2p plus 16. I don't like decimals. I know you don't like decimals either, so let's just times it by 2, get rid of it. 3p equals 4p plus 32. And move everything to one side. Minus p equals 32. P equals 30 minus 32. Okay, and that's the value of p for which u and v must be parallel. Okay. So two different versions of very similar questions there. B is not dealing with angles, it's dealing with them being parallel, so that's where this whole scale idea comes in. A, part 2, perpendicular, that is an angle, it's 90 degrees, and then you've just got to kind of jump to get an answer there. U dot V will equal 0. And because it's obviously all part of question A, you know it's probably going to be linked to the bit that you got in A part 1. Okay? Right. This is the other kind of question that you often get when we're dealing with scalar product. You get something similar to this, and there's very little information going on here, but you have to look at certain keywords and key phrases to help you here. So the diagram, that's not important, shows a right-angled isosceles triangle with equal sides 2 units long, okay? So all of that's information, all of that I'm actually going to need. Don't just try and look for numbers and pick them out. Okay, I have to use that information, and it tells me a lot about what this is. If it's right angled, then obviously I've got the 90 degree angle, I can see that there. But if it's isosceles, it tells me that 2 of the sides are the same. Quite clearly you can see that it's going to be A and B that are the same size, okay? And that's what it means by equal sides 2 units long. So both A and B are going to be 2 units long, okay? In which case, if I know in a right angled triangle 2 sides, I can work out the third side. So the first thing I want to do is probably multiply out the brackets. A dot A plus B plus C is A dot A plus A dot B plus A dot C. And then using that triangle, knowing that those 2 sides are 2 units long, I can work out the third side. Square root of 2 squared and 2 squared, which means it's root 8. Okay. I also know the angles. So because it's 90 degrees in that corner, and because it's isosceles, the 2 angles in each other corners must be the same, in which case they both add up to 90 degrees. And if they're both the same, it'll be half of that, 45 degrees. All this information comes about from those 2 bits that I've underlined. Okay, so it's very key to actually read the blooming question. Okay, right. What I'm going to need in a second, let's go back a bit so you can see that again because it's pretty snazzy. I'm going to need to find A dot A dot B, and A dot C, in which case I need to be dealing with the positive directions or the angles between the positive directions of these vectors. A dot B, I can see, is this angle down here. Okay, well this angle here, I'll do it up here because I might edit this one in a second. In which case that angle is the angle between the positive direction of A and B. For A dot A, that's easy enough, but for A and C, your eye might be drawn to this angle here, but that's not the angle between the positive direction of A and C. So what I have to do is move basically A along until such a point as it does form an angle between the positive of A and the positive of C, which is that angle there, which is 135 degrees. There's lots of little things you need to take care of to be able to do a question like this. But now I have all this information, I can expand this a little bit more. So using the expansion that I did in the first instance, A dot A becomes magnitude of A times by the magnitude of A times by the cosine of 0. Remember, we did this before. There's no angle between A and A. That will just simplify to the magnitude of A squared. A and B, angle of 90 degrees, that's all just going to simplify to 0. And A and C, I had to be very, very careful, as I say, to get the angle between the positive directions. So 2 times 2 times cos of 0 is 1. 2 times 2 times cos of 90 is 0. It's just going to disappear anyway, but I've just written it out. A and C are 2 and 8, and then the cos of 135. So we did something like this earlier. So it's equivalent to the cos of 45, but it's in the sine quadrant. So it's minus in there. So it's the same as minus cos 45. Cos 45 is 1 over root 2. So it's minus 1 over root 2. Simplify all this down. Okay, 2 times 2 times 1 is 4. 2 times 2 times 0 is 0. And then the last bit there, I'm just basically going to get minus 2. And what I've done is I've simplified the root 8 using surds. Okay, so it's root 4 root 2, which becomes 2 root 2, times by that minus 1 over root 2. Leaves us with 2 times 2 root 2 over root 2. Lots of 2's going on there, so take your time getting used to that. Okay. Now it's a case of just simplifying it as much as I possibly can. 2 times 2 is going to be 4, so it's 4 root 2, but divided by root 2 just leaves me with the 4. 4 plus 0 plus minus 4 is 0. And that's my final answer for part A at least. But part B, and this is where it's almost a clue, comment on your answer. There's only so many things we can get here. If I'm going to get the scalar product, all other numbers tell me virtually nothing. If I'm going to have to comment on my answer of a scalar product, the only thing I can really comment on is when the answer is 0. So it almost gives you a clue. If you looked ahead at part B and thought, comment on your answer, the only thing you can really comment on is when it equals 0. And what that tells me is that A, basically, in the way that I've written it, the dot product between A and A plus B and plus C is 0. Therefore, A is perpendicular to the 3 vectors added together. Okay, and that's just going back to what we had at the start. It's A dot all of these, in which case all of them added together will form a new vector, as we've looked at before, and then the dot product between A and all of those vectors added together will, because it's equal to 0, tells us that they are therefore perpendicular. Okay, so it's just linking back what we had before. We've already looked at that. Okay, we had the cos 90 in the start. It just tells us, as I say, that they are perpendicular. So you get lots of different kind of questions like that, but it's those kind of things that you're looking for. You're looking for the angles. It's often right angled. It's often isosceles. You might know a side. You need to work out angles. Careful with your positives. Okay, lots of things going on there. It looks very basic, but it can be quite an awkward question. So be careful. There's a little past paper question if you fancy doing it. Okay, I'll do it. Okay. Vectors u and v are such that u is 4, v is 5, u dot u plus v equals 21. Determine the size of the angle between the vectors u and v. Right. Very little information to go on here. We certainly don't have any angles, okay? And that's why we have to determine the size of an angle, okay? So what I'd be starting with is starting with what I can do, okay? I can expand this a little bit. So u dot u plus v, in brackets, equal to 21. I can expand that. It's going to be u dot u, it looks like a v, u dot u plus u dot v is equal to 21. Okay, right. U dot u will be the magnitude of u times by the magnitude of u times by the cosine of the angle between them, plus u dot v will be the magnitude of u times by the magnitude of v times by the cosine of the angle between them. That's what I want to find. So I'm going to need that. It's going to be my one at the end. Point is, I'm going to take care of this in a second, and that's all equal to 21. Right, angle between u and u is 0. So this is basically 4 times 4 times by the cos of 0. Be careful. Cos of 0 is not 0. U dot v is 4 times 5. And times by cos theta. That's the bit I don't know. That's what I want to find out. So that's fine staying as it is. Cos of 0 is 1. So this just becomes 16 plus 20 cos theta equals 21. Right, now what I've got is a trigonometric equation. Trying to find out what theta is, so move everything to the other side. Take away 16. It's gone thick again. 20 cos theta equals 5. Cos theta equals 5 over 20. So then theta must equal the inverse cos of 5 divided by 20. And for that, you can shove it in a calculator. Yeah, hang on. Inverse cos of 5 divided by 20 is 75.5 degrees. Okay? So it's slightly different there, but again, you start with a bunch of information. Just do what you can with that information. You can expand that. You probably get a mark just for expanding it. Okay, that's probably one of the marks. And then for substituting in your values, it's probably a second mark. And then for simplifying it down to such a point as you just left with cos theta, that's probably a third mark. Getting the answer is a fourth mark. Okay, but it's just applying a bunch of those different rules that I've shown you already.